Greetings, this is Dr. Wyatt, and this will be your first lecture on section 1.1 of your text, the real number system. I am going to try to make these videos pretty quick. They will not be like 90-minute lectures. I'm going to try to keep them under 15 minutes. It's a lot to cover in 15 minutes. Luckily, this first chapter, chapter 1, really is all a prerequisite. You should be seeing a lot of very familiar stuff from Math 95 or your Algebra 2 class in high school. So, or in some cases, Algebra 1 or even before then as we start going through some of these properties. So you will see that it is a lot of material, and it is going to be presented pretty quickly. If you have questions at all, please don't hesitate to post in the discussions on Canvas or email me or attend one of the office hour Zoom sessions. All right, so let's begin. So these are our objectives for this lesson. I'm going to spend just a few minutes on each of these, understanding the basic properties of the real numbers, understanding interval notation, representing an interval of real numbers on a number line, finding the absolute value of a real number, and simplifying expressions using order of operations. So first, let's just talk about the structure of the real numbers. We'll start with the smallest subset in the real numbers, which is called the natural numbers. Some set notation books, you'll see this as a double bar N. And that is the set 1, 2, 3, 4. Sometimes people will call these the counting numbers because they're the numbers you count with. You rarely count 0, 1. You count 1, 2, 3, 4. So these are the natural numbers. You add 0 to that and you get a set we call the whole numbers. And of course, if you ever take a history and math class, you'll learn that 0 was a very controversial concept initially. Right. You put the positive and negatives of those together and you get the next subset of the real numbers, which is the integers. And in set notation, a lot of books will use a double bar Z, and that is kind of hauled back to its Germanic roots there. So again, this is all the negative and positive whole numbers. Now, our next set is the rationals. And this is again a subset of numbers, and it is any number that can be written as a fraction of two integers. So take like 0.25. We know that can be written as 1/4. It could also be written as 25 hundredths, right? These are all, any decimal that terminates or is repeating can be written as a rational number, as a fraction. Also, any whole number can be written as a fraction. -2 is -2/1. 5 is 10/2, for example. So any whole number, any counting number, any integer can actually be written as a rational number, and any terminating decimal or non-terminating repeating decimal can be written as a rational number. Rational has the word ratio in it. It is for the ratio or fraction. That is where that name comes from. It is also sometimes called the quotient group. And because of that, it is represented in set notation as a double bar Q. And then finally, you have the irrational numbers. Now, you cannot be both rational and irrational. The definition of an irrational number are numbers that are not rational. There is no overlap. It's a binary thing. It's either this or that, nothing in between. If you combined all of the rational numbers and all of the irrational numbers together, then you get the whole real number system. So a common graphic that you might see, if this is the whole real number system is often denoted with a double bar R. Okay. Okay. If this is the whole number system, here's the rational numbers are in here. The irrational numbers are out here. There's no overlap. Inside the rational numbers, you have the integers. Inside the integers, you have the whole numbers. And inside the whole numbers, you have the natural numbers. There's only one whole number that's not natural, and that's 0. Okay? So this is what a Venn diagram would look like. You are either rational or irrational. The combination of the two make all of the real numbers. All right. Now there are properties that you have learned in the past. I'm just gonna remind you of. There's the associative property. You can think of this as a regrouping property. If you have addition, you can add these first, and then add the AN, or you can add these first and then add the CN. Likewise with multiplication, you can multiply BC first and then multiply that by A, or you can multiply AB first and then multiply that by C. Okay. There's the commutative property. Again, works for addition and multiplication. You can switch orders. Notice it doesn't work for subtraction. It's not an operation that commutes, because 10 minus 3 is not the same as 3 minus 10, but 10 plus 3 is the same as 3 plus 10. There is the distributive property. Again, this will all seem familiar, but if you have the same element multiplied over addition, you can factor that out. And this is the same as A being multiplied to B and A being multiplied to C, then adding them together, or you can add B and C together and then multiply A. There are some special elements that we'll talk about real quick, and they're called the identities. The additive identity is the number that you add to get to the inverse. So let me, actually I said that wrong. The inverses are the number that you get to the identity. So 0 is the additive identity, and that is because if you add 0 to any number, you just get 0. That number back, you just get back the number that you started with. The multiplicative identity is 1, because if you multiply 1 by anything, you just get that. You don't change the value of that anything. It just stays the same. The inverse is what you have to add to get back to the identity. So the inverse of A is the opposite of A. So the inverse of 3 is negative 3. The inverse of negative 4 is 4, so on for additive inverse. Multiplicative inverse is the reciprocal. So if I have A and I multiply it by its reciprocal, I get to 1. right? So the reciprocal of 3 is 1/3. Notice when I multiply those together, I get 3/3, which is 1, so on, right? Those are all the important properties that you would need to know. Of course, we know that we have this number line. It's a real number line. Negative infinity goes that way. Infinity goes this way. 0 is in the middle. We often call 0 our origin. Our counting numbers go up here. Our natural numbers are negative, climb down this way, so on, right? If I were looking at something like an inequality, A is less than B, for example, let's say 2 is less than X. Okay? This inequality says that every X is bigger than 2. I would draw that like this on a number line. Notice I have a filled or unfilled circle because 2 is not less than 2. 2 is equal to 2. If I wanted to fill that circle in, I would have to have a symbol that has a little line underneath it like that. If I wanted to write this in interval notation, I would write it with a parentheses and a 2, comma, infinity. This would say I want all the points on the line going from 2 to infinity, not including 2. If I wanted to include 2, I would fill in this dot. I would rewrite it as this, and I would put a bracket on my interval. All of these things would represent the same idea of all the numbers that are bigger than 2. It does not matter what order I put the variable. I could also put the variable over here. X is greater than 2, greater than or equal to 2, is the same as saying 2 is less than or equal to X. So it doesn't matter which side I put the variable, as long as they say when they're teaching this to very little kids, as long as the alligator is eating the variable each time, right? As long as this is pointing, this directional is pointing in the same direction relative to the variable and the 2. So let's go through a couple things. If I was looking at the numbers between A and B, let's say I'm including A, going to B, then I would end up with the interval, close bracket, A, B, parentheses, like that. I would write this as an inequality as A is greater than equal to X, or is less than or equal to X, which is less than B, not including the B. If I wanted to write X is less than A, any number A, here's A, not including it, all the numbers less go that way. This would be from negative infinity. You never include infinity. Infinity is always a parentheses because you can never capture, include, equal infinity. All right, so, and then up to A, not including A. If I wanted all real numbers on the graph, it would be every number here, so it would be all real numbers. And it would go from negative infinity to infinity. And you would just write all real numbers. This is table 1 from your textbook, and you can see how it runs down through these possible things that you have. Please take close notice of whether it's a bracket or a parentheses. You can see a bracket includes the dot, and a parentheses does not include the dot. So that's a really important, again, thing to keep in mind. All right, let's talk a little bit about the absolute value. The definition of the absolute value is just the distance away from 0. Right? So it is a distance metric. It's the magnitude of a value from 0. So if I have 4, it took me 4 steps to get there. So if I put 4 into the absolute value, I say, well, it took me 4 steps to get to 0. Non-directional, 4 steps. Right? If I go a -4, it also takes me 4 steps to get to 0. If I wanted to write this function as a piecewise function, whenever x is positive, then you just get x out. For anything, when x is positive, greater than or equal to 0, you just get x out. But if x is negative, then you get the opposite of x out. So if x is negative, you're taking the opposite of x, so it becomes positive. So things go in, come out. If I'm graphing this in a 2-dimensional graph, if this is the x's and this is the y's, when I have 0, I get 0 out. When I have 1, I get 1 out. When I have 2, I get 2 out. And it looks like a line going this way. When I have -1, I have 1 out as well. When I have 2, I get -2, I get 2 out as well. 3, I get -3, I get 3 out, and so on. It looks like a line going that way. So this is the graph of the absolute value. Important, like couple things that you need to know. These are always greater than or equal to 0. If they say, hey, what is the absolute value is less than or equal to -3, right? This has no solutions. This has no solutions because you can't put something in and have it be less than -3. Likewise, if I say the absolute value is greater than -4, this would be all real numbers. Because anything I put into the absolute value is always going to be greater than -4. So absolute value is always greater than 0. If I have a product of absolute value in an absolute value, I can take it one by one. Same with multiplication. Division is what I meant to say. Right? We know that the absolute value of the opposite of A is always the same as the absolute value of A, no matter what sign that is. And if I take B minus A, right, that is going to be equal to A minus B in absolute value. So you can switch them. It's always going to be the distance between the two numbers of the absolute value lines on a number line. So that's helpful. Right? And finally, I'm just going to briefly remind you about the order of operations. I'm sure you learned this 100 times in school. Please excuse my dear Aunt Sally. Okay, please keep in mind the problem with this mnemonic is that it makes it seem like 3, let's say if I did 6 divided by 3 times 2, right? Because of this mnemonic, so many kids will be like, multiply comes first, so this is equal to 6 divided by 6, which is equal to 1. That is not true. These guys are lined up like this because multiplication and division are on the same level. Addition and subtraction come last, but they come on the same level from left to right, and this is for parentheses and exponents. So the correct way to do this is left to right, because multiplication and division are on the same level. It should be 6 divided by 3, which is 2, times 2, which is 4. Okay? So again, this is a really common mistake. They're always trying to multiply first. You multiply and divide from left to right on the same level. You add and subtract from left to right on the same level. and then you have your parentheses. If you're using a calculator, make very, very sure that you are using as many parentheses as possible to get it right. So on the calculator, this should be typed into 6 divided by 3 times 2. Okay. I hope that is helpful, and go ahead and jump into your My Open Math assignment, and you'll get to practice all of these techniques. Thanks so much. Bye.